All right, so we're going to go getting started here on, well, continuing on with 3.1, but we're going to get started with a new form for graphing. Sometimes we don't have it in the form that we were looking at before. We were looking at f of x equals, I don't want that light green, hold on. We had f of x equals a times x minus h squared plus k. But what do you do if it's not in that form? What if you get it in the more typical form there that looks more like a polynomial there? The f of x equals ax squared plus bx plus c. And this is, when it's in this form, we can actually go ahead and still get a lot of information straight from it and figure out how to graph it. So the first thing we can do is we want to find h and k. Remember, the location of our vertex, right, was at hk. So how do we get h and k from this? From our previous form, we just simply picked it out right there and right there. In this one, it's not quite so straightforward. It turns out that we can calculate what h is by doing h equals negative b divided by 2a. If you're interested ever in learning where this comes from, or at least an easy way to figure it out in case you ever forget it, then you have to basically go take calculus for it. So deriving that, what h equals, is actually pretty straightforward to do just using calculus, and it just takes a couple steps. But without it, it wouldn't make much sense for me to show you. So that gets us the h value, that gets us the x value. Then if you want to find the k value, the y value for the vertex, you simply plug your h value back into the function for x. And so basically you're going to start here, you're going to find that first, and then you're going to plug it in. So find h and then plug it in to get your vertex location. So let's go ahead and take a look at this. Also, we can do the same sort of thing where we can look at a and determine if it's up parabola or a down parabola. So we look at this. Part A says, excuse me, determine if the parabola opens up or down. For our function here, x squared plus 2x equals 8. Well, here we have a equals 1. Therefore, this parabola opens up. All right, it opens upward like that because that a is 1. If we then wanted to go through and find the vertex, we would start with h equals negative b over 2a, negative b over 2a. So we look up here at our equation. B is the coefficient right in front of the x right there. So in this case, b is 2. So we put negative 2. And then we divide it by 2 times a. And in this case, we already said a was 1. So we get that. This ends up with negative 2 over 2, which is just negative 1. So now we have the actual value for, it, and we can plug that into our function. We can do f of h like that and get what k is. So k is going to equal that of h when we plug it in. So this will be f of negative 1. So we plug in negative 1. Negative 1 squared plus 2 times negative 1 minus 8. Negative 1 squared is just 1. 2 times negative 1 is a negative 2, and then minus 8. We put all those together, and you should get negative 9. So therefore, our vertex is at negative 1, negative 9, just like that. And now, what we can do is move on. It says, determine the axis of symmetry, just like we were doing before. Again, same exact thing. We're going to take our vertex. We're going to pick out that x coordinate and just write x equals negative 1 right there. There's our axis of symmetry. To find any x-intercepts, we do the same thing. It's just a matter of let y equals 0 and then solve for x. So after our first couple steps, it turns out just to be the same as what we were doing before. So this would be 0 equals x squared plus 2x minus 8. And then we just have to solve that. We can actually factor this. This would factor to x plus 4 times x minus 2. All right, negative 2 times 4 is that negative 8. and negative 2 plus 4 is the 2. So that's our negative 8 and our 2 right there. They add to 2 and they multiply to negative 8. That then tells us that x plus 4 has to equal 0 and x minus 2 has to equal 0, or x minus 2 has to equal 0. So x equals negative 4 is the answer for that first one, and x equals 2 is the other one. So we have two x-intercepts. So that gives us x-intercepts at negative 4, 0, and at 0, like that. After that, it says find any y-intercepts. We do that by letting x equal 0. In this case, we get y equals 0 squared plus 2 times 0 minus 8. That's just a 0, that's just a 0, and we're left with just y equals negative 8. And so therefore we have a y-intercept at 0, negative 8, just like that. And then the last thing is determining the domain and range. That I would like to do after we graph it, just so it's a little easier. But if you're good at it, you can go ahead and do it now. So first thing we have is our vertex right here. I'll put a box around it in red, and then it's at negative 1, negative 9. So that goes right there. Next, we have our x-intercepts. I'll put a box around those in purple and drew those in purple here. So then that goes to negative 4, 0, that's right there. And then of course 2, 0 right there. After that, we have a y-intercept that occurs at 0, negative 8 right there. So 0, negative 8 is right there. We can also put in our axis of symmetry. I'll do that here with light green. And so this is our axis of symmetry, which means if we have any points to the left of it, we can just duplicate them to the right, which means I can come down here to this blue point and just duplicate one just to the left on there. And now all that's left to do is to sketch in the actual curve. And so this curves down like this, curves back up like that. And there you go. There's the graph of our function. The last part you would do is to determine the domain and range. Just like before, the domain is just going to be negative infinity to positive infinity for all of these parabolas. And then the range we have to actually look at and figure out. And when we look here, we see that we never go below the vertex because this is an opening up parabola. Therefore, we never get to any values down here, and we only have the values up here going up to infinity. So our range in this case is going to be, if I get rid of, is going to be inclusive of negative 9 and then all the way out to infinity, but not inclusive of infinity. All right, so that's pretty much how we do that one. I will let you try the next one on the next page, and I'm going to go ahead and pause to let y'all do that and ask me any questions you may have. All right, so taking a look at this one here, we have x squared minus 2x plus 1. You can see the parabola that resulted from it and what our range was, 0 to infinity. Here on this one, we're essentially going to do a very similar function, but this time it's just all multiplied by negative 1. So the x squared became negative, the 2x became positive, and the 1 became negative. So let's determine first if the parabola opens up or down. In this case, it's going to open down. And it's going to do that because now a equals negative 1. That's that negative right in front. We have a equals negative 1. For this one right here, we have b equals 2. All right, so first off, it's opening down, and it's opening down because a equals negative 1. So now we need to find h. H is negative b over 2a. So this is negative of b, which is 2, so negative 2 over 2 times negative 1. And so this will be negative 2 over negative 2, which will just be 1. So we'll have a value of 1 for h. To find k, we simply plug h back in to our function. So this is f of 1. And so we get negative 1 squared plus 2 times 1 minus 1, just like that. And then we end up with negative 1. So it's 1 squared and then make it negative. So this is negative 1 plus 2 minus 1. So again, what we have here is negative 2 plus 2. This is 0. And so we end up with the point 1, 0 as our vertex. Okay. Now, determine the axis of symmetry. It's going to be the same as the previous one, just x equals 1. We just grab that x value from our vertex and we're done. Determine any x-intercepts. So find any x-intercepts. So we, again, let y equals 0, and we get 0 equals negative x squared plus 2x minus 1. All right, if we take that, we can go through and solve for when we get this, and we can factor out this negative. We can make this negative of x squared minus 2x plus 1, just like that, equals 0. And when you do that, we see that we're back to the same thing that we had before. We can multiply both sides by negative 1. So times negative 1 times negative 1 to cancel out. That'll cancel out that negative. And the 0 times negative 1 is just 0. So we end up with 0 equals x squared minus 2x plus 1, which is what we had in the previous one, where we found that x minus 1 times x minus 1 was how we'd factor this. And so that gives us our one single solution of x equals 1 and gives us a vertex of 1, 0 again, or an x-intercept of 1, 0 again, which just like before, in the previous one, matches with our vertex. Since our vertex is hitting at x or at y equals 0, it is intersecting our x-axis. So now we can find any y-intercepts. We do this by letting x equal 0. So this will be negative 0 squared plus 2 times 0, and then minus 1. This is a 0, this is a 0, and we end up with just y equals negative 1. So here, it's different. In the previous one, we got y equals 1. Now we have y equals negative 1, which means we have a y-intercept of 0, negative 1, which is good because in the previous example, this is where our vertex was and it opened up like that, but we are expecting this one to open down. And since it's opening down, we should have a y-intersection occurring down below the axis in the with a negative value, which is what we got. We got a y equals negative 1 for our x-intercept. All right, so let's go ahead and finish sketching this up nicely. So again, our vertex is 1, 0, which is also our x-intercept. We have a y-intercept of 0, negative 1. That's right there. Our axis of symmetry is at x equals 1, so the same as the previous one. We can then mirror image this point right there, the 0, negative 1 point. We can mirror image that across that line just like that. And then it's just a matter of sketching in our parabola. So if you compare these two, what you'd see is we multiplied that whole thing by negative 1, and all it ended up doing was flipping our parabola over, just like that. We just flipped it over, which should fit with your understanding of, we essentially said that we have f of x equals negative of the previous one. So if the previous one was g of x, it's negative out in front, which is that vertical or flip over the x-axis. And that's what we did here, and that's how it worked out. So now when we look at the domain, it's still that same domain of negative infinity to positive infinity, but now our range this time is all the way down at negative infinity. That's the lowest we can get, but we can get all the way up to 0, but we can never, so we never get into that region up there. We never get above 0, so it's negative infinity up to and including 0. All right, so there is that one. Again, I encourage you to compare it with the one on the previous page to see what happens when we just multiply that negative 1 and if it fits with your understanding of how we did transformations. All right, so I'm gonna go and check for questions. All right, so last thing to think about is extreme values of the parabola. And so essentially, whenever A is a positive number, we're going to end up with a minimum. So when A is greater than 0, it's positive, then our function is opening upward. Then it opens up. And when it opens up, that means it looks like this, right? And so wherever this lowest vertex point is actually going to be a minimum. It's the lowest that we ever get. And so whenever it opens up or whenever A is positive, we have a minimum value on our function. Conversely, if A is less than 0, in other words, A is a negative number, then our function opens down and our graph is faced like this. And instead of having a minimum, this is actually the highest point. So on this one up here, this is a minimum of the graph. On this one down here, when it opens down, it's a maximum of the graph. So we have a maximum or a minimum depending on whether or not it's opened up or opened down. So for example, let's take a look at number 8. It says, consider the quadratic function f of x equals negative 3x squared plus 6x minus 13. Determine without graphing whether the function has a minimum value or a maximum value. So I look at this one and I see that a equals negative 3. That's that negative 3 right there. Since it is negative, it's negative. That means this opens down. And since it opens down, this function has a maximum. It has no minimum because this just continues on down to infinity forever when it opens down to negative infinity. But it doesn't ever go above that vertex point. So that vertex point becomes a maximum. So then it says, find the minimum or maximum value where it occurs. So this occurs at the vertex. So what we can do is take this and we can find the vertex, right? A equals negative 3, B equals 6. And so our vertex H is negative B over 2A. That's going to be negative 6 over 2 times negative 3. That's negative 6 over negative 6. That's a 1. So our value for H is 1. And so that tells us the X value of our maximum, but we're interested in what the actual maximum is. So we need to go through and find the K value. That's our Y value. That's the actual value that you get at X equals 1, and therefore is our largest value. So we're going to do F of 1, and that's going to be negative 3 times 1 squared plus 6 times 1 minus 13. So negative 3 times, well, 1 squared is 1, so negative 3 times 1 is negative 3, plus 6 times 1 is 6, minus 13. So this is going to be negative 10. So our maximum value here, the maximum value that we'll end up getting is that negative 10. So if you graphed this, you know, it says to do it without graphing, we'd be down here at negative 10, positive 1, it would be shaped like this, and 10 would be the highest that our graph would get to. All right, and I'm not going to leave that there because it says do it without graphing. And then identify the function's domain and range. Domain, same as it was before, negative infinity to positive infinity. And then the range, we know this is a maximum. And so we go and start down here at negative infinity and go up to that maximum of negative 10, just like that. All right, and that's our domain and our range for it. All right, so let me pause it to see if there's any questions.